Azure Redis Essentials for Beginners Part 2. Hello and welcome to our channel, Enthusiastic Tech Learner. Today we have an exciting tech video in store for you. We'll be diving into Azure Redis Cache basics, exploring its features, and providing you with valuable insights. Whether you're a tech enthusiast, a beginner, or just curious about the latest in the tech world, you're in the right place. So without further ado, let's jump right into it. Topics covered in this video: Redis Cache tiers: Basic, Standard, Premium, Enterprise, Enterprise Flash. Redis Cache tiers comparison. Redis version. Redis best practices while using client library for connection resilience. Redis best practices when developing client applications that interact with Azure Cache for Redis. Best practices for memory management when using Azure Cache for Redis. Eviction policy in Azure Redis Cache. 1. Redis Cache tiers: Basic, Standard, Premium, Enterprise, Enterprise Flash. Azure Cache for Redis provides an in-memory data store based on the Redis software. Redis improves the performance and scalability of an application that uses back-end data stores heavily. It's able to process large volumes of application requests by keeping frequently accessed data in the server memory, which can be written to and read from quickly. Redis brings a critical low latency and high throughput data storage solution to modern applications. Azure Cache for Redis offers both the Redis open source OSS Redis and a commercial product from Redis Incorporated, Redis Enterprise, as a managed service. It provides secure and dedicated Redis server instances and full Redis API compatibility. The service is operated by Microsoft, hosted on Azure, and usable by any application within or outside of Azure. Basic tier. Description: an OSS Redis cache running on a single VM. The basic tier is the most cost-effective option and is suitable for non-production workloads, such as development and testing. Features: single-node Redis, no data replication. No SLA, service level agreement, guarantee. Use cases: development and testing environments with low traffic. Non-critical applications. 2. Standard tier. Description: an OSS Redis cache running on 2 VMs in a replicated configuration. The standard tier is designed for small to medium-sized production workloads with improved reliability and features. Features: data replication with one replica for high availability. Offers a 99.9% SLA guarantee. Use cases: web and mobile applications with moderate traffic. Small to medium-sized production workloads. 3. Premium tier. Description: high-performance OSS Redis caches. This tier offers higher throughput, lower latency, better availability, and more features. Premium caches are deployed on more powerful VMs compared to the VMs for basic or standard caches. The premium tier is optimized for mission-critical applications that require high performance, scalability, and advanced features. Features: data replication with up to 1 writable and 5 read-only replicas. Clustering support for horizontal scaling. Offers a 99.99% SLA guarantee. Virtual network, VNet, support and access through private link for enhanced security. Enhanced security features. Use cases: high transaction applications. Real-time analytics. Gaming applications and e-commerce platforms. 4. Enterprise tier, Redis Enterprise. Description: high-performance caches powered by Redis Incorporated's Redis Enterprise software. Redis Enterprise is a fully managed, highly available, and scalable Redis service with advanced capabilities. Features: advanced persistence options like RDB snapshots, AF logs, and hybrid persistence. Active Geo-Replication for automatic data synchronization across regions. Fine-grained access control. Active global distribution with strong consistency. Guaranteed high availability with zero downtime scaling. Dynamic clustering and sharding for optimal performance. Use cases. Enterprise-grade applications with demanding performance and availability requirements. 5. Enterprise Flash, Redis Enterprise. Description: cost-effective large caches powered by Redis Incorporated's Redis Enterprise software. This tier extends Redis data storage to non-volatile memory, which is cheaper than DRAM on a VM. It reduces the overall per GB memory cost. Choosing the right tier depends on your application's specific needs, including performance, availability, scalability, and budget considerations. Basic and standard tiers are suitable for lower traffic and non-critical applications, while premium and enterprise tiers offer more advanced features and are designed for high-performance and mission-critical use cases. Always check the Azure Redis Cache service page for the most up-to-date information on available tiers and their features, as offerings may evolve over time. 2. Redis Cache Tiers Comparison. Here's a feature description for each of the Azure Redis Cache tiers: Basic, Standard, Premium, Enterprise, and Enterprise Flash based on the provided information. Service Level Agreement, SLA. Basic, not specified. Standard, offers a 99.9% SLA guarantee. Premium, offers a 99.99% SLA guarantee. Enterprise, offers a guaranteed high availability SLA. Enterprise Flash, offers a guaranteed high availability SLA. Data encryption in transit. All tiers Basic, Standard, Premium, Enterprise, Enterprise Flash support data encryption in transit, ensuring data security while it's transferred over the network. Network isolation. All tiers Basic, Standard, Premium, Enterprise, Enterprise Flash provide network isolation to secure the Redis cache within a specified network boundary. Scaling. All tiers Basic, Standard, Premium, Enterprise, Enterprise Flash support scaling to handle increased workloads. Scaling options may vary, with the Premium and Enterprise tiers offering more advanced scaling features. OSS clustering. Basic and Standard tiers do not support OSS open source software clustering. Premium, Enterprise, and Enterprise Flash tiers support OSS clustering for improved performance and scalability. Data persistence. Basic and Standard tiers do not mention data persistence. Premium and Enterprise tiers support data persistence, ensuring data durability even in the event of cache restarts or failures. This feature is in preview for Premium. Enterprise Flash also has preview data persistence. Zone redundancy. Basic and Standard tiers do not support zone redundancy. Premium, Enterprise, and Enterprise Flash tiers offer zone redundancy for enhanced data availability and fault tolerance. Geo-Replication. Basic and Standard tiers do not support geo-replication. Premium tier supports passive geo-replication, where data is replicated to a different region for disaster recovery. Enterprise and Enterprise Flash tiers support active geo-replication, enabling data synchronization across regions for high availability. Connection audit logs. Basic and Standard tiers do not provide connection audit logs. Premium, Enterprise, and Enterprise Flash tiers offer connection audit logs, with different methods for event-based or pull-based auditing. Redis modules. Redis modules are supported in the Enterprise tier, offering extensibility and customization options for Redis functionality. Import, export. Premium, Enterprise, and Enterprise Flash tiers support import, export of data, allowing for data migration and backup operations. Reboot. Reboot capability is available in the Basic, Standard, and Premium tiers for cache management purposes. It is not mentioned for the Enterprise and Enterprise Flash tiers. Scheduled updates. Scheduled updates such as patching and maintenance are available in the basic, standard, and premium tiers for proactive cache management. They are not mentioned for the Enterprise and Enterprise Flash tiers. Please note that the availability of some features may change over time as Azure Redis Cache evolves. Always refer to the official Azure Redis Cache documentation for the most up-to-date information on features and capabilities for each tier. 3. Redis version upgrade from 4 to 6. Azure Cache for Redis supports upgrading the version of your Azure Cache for Redis from Redis 4 to Redis 6. Upgrading is similar to regular monthly maintenance. Upgrading follows the same pattern as maintenance. First, the Redis version on the replica node is updated, followed by an update to the primary node. Your client application should treat the upgrade operation exactly like a planned maintenance event. As a precautionary step, we recommend exporting the data from your existing Redis 4 cache and testing your client application with a Redis 6 cache in a lower environment before upgrading. Limitations. When you upgrade a cache in the basic tier, it's unavailable for several minutes and results in data loss. Upgrading on Geo-Replicated cache isn't supported. You must manually unlink the cache instances before upgrading. Upgrading a cache with a dependency on cloud services isn't supported. You should migrate your cache instance to virtual machine scale set before upgrading. When trying to upgrade to Redis 6, your VNet must be configured in accord with the requirements. Your upgrade might fail or the cache might not function properly after the upgrade if not configured correctly. You can upgrade your existing Redis 4 caches to Redis 6. Upgrading your cache instance is permanent and you can't downgrade your Redis 6 caches to Redis 4 caches. 4. Redis best practices while using client library for connection resilience. Connection resilience in Azure Redis Cache refers to the ability of a client application to maintain a reliable and robust connection to the Redis cache server, even in the face of network disruptions, temporary outages, or other issues that might cause interruptions in communication between the client and the cache. Here are some key aspects of connection resilience in Azure Redis Cache. Automatic reconnection. Azure Redis Cache client libraries, such as the Stack Exchange, Redis Library for .NET, provide built-in features for automatic reconnection. When a network interruption occurs, the library will attempt to automatically re-establish the connection to the Redis server. Retry logic. Connection resilience often involves implementing retry logic in your application code. This means that if a connection attempt fails, the application will retry the connection after a brief delay. Retrying helps handle transient network issues that may resolve themselves. Connect TCP settings for Linux-hosted clients. Linux systems may have default TCP settings that can cause Redis server connections to fail for extended periods, such as 13 minutes. These settings can prevent the client application from detecting and restoring closed connections in situations like network disruptions or Redis server maintenance. It's recommended to adjust the net.ipv4.tcp_retries to setting to a value of 5, using Force Reconnect with Stack Exchange, Redis. In rare cases, the Stack Exchange, Redis library may fail to automatically reconnect after a connection is dropped. To address this, consider implementing a singleton connection multiplexer pattern and allowing apps to periodically force a reconnection. Examples of this code pattern can be found in Quick Start sample projects. Configure appropriate timeouts. Timeout. Set a connect timeout of 5 seconds to allow sufficient time for the client to establish a connection, even under high CPU conditions. Command timeout. Adjust the command timeout based on your specific scenario and the sizes of cached values. A balance between a too small and too large timeout is essential to maintain a stable connection without extended wait times. Avoid client connection spikes. When reconnecting after a connection loss, avoid creating numerous connections simultaneously. Starting many reconnect attempts at the same time can increase server load and prolong the reconnection process. Consider staggering new connections to mitigate this issue. Avoid leftover connections. Ensure that when your client application recreates connections, it closes and removes the old connections to prevent exceeding cache tier limits. Advanced maintenance notification. Use notifications to stay informed about upcoming maintenance activities to prepare your application. Refer to "Can I be notified in advance of plant maintenance" for details. Schedule maintenance window. Adjust your cache settings to accommodate maintenance activities and minimize negative impacts on your cache. Learn how to create a maintenance window for your cache in the Schedule Updates section. Idle timeout. Azure Cache for Redis has a 10-minute timeout for idle connections, which allows the server to clean up unused or orphaned connections. If your connections may be idle for close to 10 minutes, configure a keep alive interval less than 10 minutes to maintain active connections. Most Redis client libraries support sending periodic heartbeat or keep alive commands. Implement keep alive functionality if your library lacks native support by periodically sending a ping command from your application. Connection pools. Most Redis client libraries, including those for Azure Redis Cache, use connection pooling. Connection pools maintain a pool of open connections to the Redis server, allowing your application to efficiently reuse connections and minimize the overhead of creating new connections for each request. Keep alive mechanisms. Some client libraries and networking configurations include keep alive mechanisms that periodically send ping requests to the Redis server to ensure the connection remains active. This helps detect and recover from connection failures more quickly. Circuit breakers. Advanced connection resilience strategies may incorporate circuit breakers. Circuit breakers monitor the health of the Redis connection and can temporarily open the circuit if too many connection failures occur in a short period. This prevents the application from repeatedly trying to connect when the Redis server is unavailable. Error handling. Effective error handling is essential for connection resilience. Your application should catch and handle exceptions related to Redis connection issues gracefully, potentially logging errors for diagnostics. Retry policies. You can configure retry policies with parameters like the number of retry attempts and the delay between attempts. These policies can be customized to suit your application's requirements. Monitoring and alerting. Implement monitoring and alerting mechanisms to be notified of Redis cache connection issues. Azure Monitor, for example, can help you track cache health and performance. Connection resilience is crucial for ensuring the availability and reliability of your Redis cache-dependent applications. By implementing the right strategies and leveraging client libraries with built-in features, you can minimize disruptions caused by network issues and maintain a consistent and resilient connection to your Azure Redis Cache. 5. Redis best practices when developing client applications that interact with Azure Cache for Redis. This article highlights the importance of considering connection resilience and managing server load when developing client applications that interact with Azure Cache for Redis. Here's a breakdown of the key points. Smaller values, more keys. Azure Cache for Redis is optimized for smaller values. It's advisable to split larger data into smaller chunks and distribute them across multiple keys. This approach enhances caching efficiency. Dealing with large request/response sizes. Large request or response sizes can lead to timeouts. For instance, if your application has a 1-second timeout, and it simultaneously requests two keys, example, A and B. If response A is large, it may consume most of the timeout period, causing B to timeout even though the server responded quickly. Key distribution in Redis clustering. If you plan to implement Redis clustering, it's essential to read the Redis clustering best practices, especially focusing on key distribution resolutions for large response sizes. To address large response sizes, several strategies can be employed. Optimize your application for handling a larger number of small values rather than a few large ones. Consider breaking down your data into smaller, related values to improve performance. Evaluate the possibility of increasing the VM size to boost bandwidth capabilities, reducing data transfer times for larger responses. Assess the network usage on both the client and server VMs, comparing it to the VM size limits. Increasing bandwidth on either side may not suffice. Enhance connection management by increasing the number of connection objects in your application and using a round-robin approach to distribute requests across these connections. Pipelining. Choose a Redis client that supports Redis pipelining. Pipelining enhances network efficiency and maximizes throughput, improving the overall performance of your Redis cache. Avoid costly operations. Certain Redis operations, such as the keys command, can be resource-intensive and should be avoided whenever possible. Consider alternative approaches to maintain efficient cache operations. Appropriate cache tier selection. For production systems, opt for one of the following tiers: Standard, Premium, Enterprise, or Enterprise Flash. Avoid using the basic tier in production as it lacks data replication and doesn't offer an SLA. Additionally, it's recommended to use a C1 cache at a minimum. C0 caches are better suited for simpler development and testing scenarios due to their resource limitations. Performance testing. Conduct performance testing to select the correct cache tier and validate connection settings. This ensures that your cache configuration meets the performance requirements of your application. Region alignment. To minimize latency and enhance reliability, position your cache instance and application in the same Azure region. Connecting to a cache in a different region can result in significant latency. Hostname usage. Instead of relying on explicit public IP addresses, it's advisable to use hostnames when accessing your cache. Public IP addresses can change due to scaling operations or backend improvements. Redis version selection. Be aware that the default Redis version used for cache creation can change over time. If your application depends on a specific Redis version, explicitly select that version during cache creation. Enterprise tier specifics. Keep in mind that the Enterprise and Enterprise Flash tiers are built on Redis Enterprise, which differs from open-source Redis. By implementing these strategies and considering the impact of data size on your application's performance, you can ensure smoother interactions with Azure Cache for Redis while maintaining connection resilience and managing server load effectively. 6. Best practices for memory management when using Azure Cache for Redis. Eviction policy. Choose an eviction policy that aligns with your application's requirements. The default policy is volatile root, which evicts keys with the TTL time to live value set. If you want the system to evict any key when under memory pressure, consider using the auxiliary policy. Keys expiration. Set expiration values on your keys using commands like expire and expiriate. This proactive approach removes keys before memory pressure triggers eviction, reducing server load. Minimize memory fragmentation. Large values can lead to memory fragmentation upon eviction, causing high memory usage and server load. Be mindful of the size of values you store to minimize fragmentation. Monitor memory usage. Implement monitoring for memory usage to ensure you have insights into your cache's memory consumption. Monitoring helps you avoid running out of memory and provides the opportunity to scale your cache preemptively. Configure max memory reserved setting. Adjust the max memory reserved setting to enhance system responsiveness, especially for write-heavy workloads or when storing large values, 100 kilobytes or more, in your cache. By default, around 10% of available memory is reserved for max memory reserved. You can increase this reservation if your workload involves significant write operations. Max memory reserved. This setting determines the amount of memory, in MB per instance in a cluster, reserved for non-cache operations like replication during failover. Setting it higher ensures a more consistent Redis server experience when load varies. This value should be increased for workloads with heavy write activity. The allowed range is 10% to 60% of max memory. Max fragmentation memory reserved. This setting reserves memory, in MB per instance in a cluster, to accommodate memory fragmentation. It helps maintain a consistent Redis server experience when the cache is nearly full and fragmentation is high. Similar to max memory reserved, this value should be adjusted based on your workload. The allowed range is also 10% to 60% of max memory. Note: changing these values may impact a cache with existing data, potentially leading to data eviction, increased server load, and memory fragmentation. Scaling considerations. When scaling your cache up or down, both max memory reserved and max fragmentation memory reserved settings automatically adjust in proportion to the cache size. Be aware that when scaling programmatically using tools like PowerShell, CLI, or REST API, these memory settings may be ignored as part of the update request. They can be updated after the scaling operation is completed. By following these memory management best practices, you can optimize the performance, efficiency, and reliability of your Azure cache for Redis deployment while ensuring effective memory usage. 7. Eviction policy in Azure Redis Cache. Eviction policy in Azure Redis Cache refers to the rules or strategies used to decide which data or keys to remove from the cache when it approaches its memory limit. When a Redis cache is configured with limited memory and new data is added, it may reach a point where there's not enough memory to store additional data. In such cases, the eviction policy determines which existing data should be evicted or removed from the cache to make space for new data. Azure Redis Cache supports different eviction policies including Volatile RU. This is the default eviction policy. It removes the least recently used LRU keys with a time to live TTL set keys that have an expiration time. This policy ensures that keys with an expiration time are prioritized for eviction, helping to manage cache data with specific lifetimes. Akizaru. This policy removes the least recently used LRU keys regardless of whether they have a TTL set. Unlike Volatile RU, this policy considers all keys in the cache for eviction, including those without expiration times. Volatile TTL. This policy evicts keys based on their time to live TTL values. Keys with the shortest TTL are removed first, ensuring that keys with shorter lifetimes are prioritized for eviction. Volatile Random. This policy randomly selects and evicts keys with a TTL set. It introduces randomness into the eviction process, which can be useful in some scenarios. Aki's Random. Similar to Volatile Random, this policy randomly selects and evicts keys, but it considers all keys in the cache, including those without expiration times. Volatile F. This policy removes keys based on the least frequently used LFU algorithm among keys with a TTL set. Keys that are accessed less frequently are considered for eviction. Akizlfo. This policy uses the least frequently used LFU algorithm to evict keys, regardless of whether they have a TTL set. It considers all keys in the cache for eviction. The choice of eviction policy depends on your specific use case and data management requirements. For example, if you want to ensure that keys with expiration times are prioritized for eviction, you can stick with the default Volatile RU policy. If you want a more balanced approach that considers all keys, you might choose Akizaru or one of the other policies. It's essential to select an eviction policy that aligns with your application's data access patterns and memory management needs to optimize the performance and efficiency of your Azure Redis Cache. How to implement eviction policy. Implementing an eviction policy in Azure Redis Cache involves configuring the desired eviction policy when you create or configure your Redis Cache instance. Here are the steps to implement an eviction policy. Access Azure Portal. Log into the Azure Portal, https://portal.azure.com. Create or select Redis Cache. If you don't have an existing Azure Redis Cache, you can create one by following these steps. Click the plus Create a Resource button. Search for Azure Cache for Redis in the marketplace and select it. Configure the cache settings, including resource group, cache name, location, pricing tier, etc. In the Advanced section, you can choose the desired eviction policy from the Eviction drop-down menu. If you have an existing Redis cache, you can configure its eviction policy as follows. Navigate to your Redis cache instance in the Azure portal. In the left-hand menu under Settings, select Configuration. Configure eviction policy. In the Configuration section, you'll find various settings for your Redis cache. Locate the eviction or eviction policy setting depending on the Azure portal's interface. From the drop-down menu, select the eviction policy that suits your requirements. You can choose from options like Volatile Root, Awkey's Root, Volatile TTL, Volatile Random, Awkey's Random, Volatile Alpha, and Awkey's Alpha. Save changes. After selecting the desired eviction policy, save the changes to apply the new policy to your Redis cache instance. Monitor and adjust. Once the eviction policy is configured, monitor your Redis cache's behavior to ensure it aligns with your expectations and performance needs. You can adjust the eviction policy later if your requirements change or based on your observations of cache behavior. Remember that the choice of eviction policy should be based on your specific use case and data access patterns. Each eviction policy has its advantages and trade-offs, so select the one that best meets your application's needs for managing data in the cache. Please note that making changes to the eviction policy may result in the eviction of existing keys from the cache, so it's essential to plan and test the configuration changes in a controlled environment if you're switching to a different eviction policy.
Hey, if you like the content, please subscribe to my channel. Don't forget to ring the notification bell so you never miss a bite of Azure brilliance.